Hello again, this is Professor Luchin with Lecture 19 for Safety 380, Introduction to Occupational Safety and Health. In this lecture, we're going to cover kind of a broad range of different types of struck by and caught in hazards. And also, there are more chapters assigned to reading this week than you've had before. Please use the study sheet as a guide to help you skim them. It's just what's interesting is, I had spoken just last week about how they don't have a specific chapter to slips, trips, and falls. They kind of just sprinkle it on. But then they've got volumes of chapters dedicated to different types of equipment that all have the same sort of hazard, the struck by caught in. So we'll talk about machine guarding, and we'll talk about lockout tagout as well. And it would help if I was on the right screen. So again, you see all these chapters meant to skim. I want you to get a sort of a broad, generalized awareness of all the different types. Because here's the thing: whether you're working with a hand power tool or your typical table saw or cutting piece of equipment, or if you're in an industrial power press, lathe, CNC machine, knowing what the point of operation can do to the operator and how they need to access it, because they have to probably somehow control the insert of raw materials to it. If you can just keep it so that their hands are away and their face and body are protected, that's what it's all about. It's kind of all the same thing. It's just the chapter spreads it out, or the book spreads it out over several chapters. So going over the same data that provided in the two previous lectures, we're now talking about contact. It is the third most frequent cause of non-fatal workplace injuries with days away from work. And then you can see after that, it really drops down quite a bit. It's okay. There wasn't anything on the front page, but in the Liberty Mutual Workplace Safety Index, struck by caught in is 3 of the top 10. I think that's interesting that overexertion's on there a bunch of times, falls are on there a bunch of times, struck by caught in a bunch of the times. The only thing we're not addressing in this class, based on this thing here, is the roadway incidents. And then you can see there was 1 in the top 5. So not as costly, not as frequent as overexertion and slip, trips, and falls, but still requires attention, because almost every day, every shift, every workplace, somebody is using some piece of equipment that if their fingers, arms, face, hair, foot were to get too close to the point of operation, it could cause a serious injury. So the type of the injuries are broad, and I love the dude with the goose egg on the forehead. That's definitely a struck by accident. So contusions, concussions, eye injuries from projectiles. Something we don't usually think about with struck by caught in would be things that stick into the eye, and we've got a beautiful picture of looks like maybe a nail sticking out of an eye. Hope you had your lunch before this. And then we've got pinch, crush, laceration. Those are common ones too. And then amputation and death is definitely an issue. You don't have to search on YouTube for long to find people who've been pulled into machines, or a machine does, expels its energy to a person. The bottom left, somebody actually got their hair too close to this turning or this sprocket, and it scalped her. Not a good Monday. So hand and power tools are covered in chapter 20. Considered the most dangerous hand tool is the chainsaw. Because a chainsaw does not just cut like a blade, it chews. And so if it contacts human flesh, it doesn't just provide a laceration, it gouges. It takes a lot out. So, and the thing is, when you're working with a chainsaw, it's a powerful tool. If you don't have a stable base and you're not controlling it with 2 hands, and you don't have the proper, and you know what you're doing, there can be kickback, because you can hit like a knot, or the thing you're cutting can bend and catch, and it can kick back. So it can hit your head, it can hit an arm, it can hit a leg, which is why you need to be basically head to toe PPE whenever you're using a chainsaw, and you need to be very, very careful. Don't like force cut, let the machine do the work. It's a scary piece of equipment. Not to say these other ones like the hammer drill bottom left, the pneumatic nailer top right, or the angle grinder, they can have issues too. But in any sort of saw, I actually got my finger not caught in, but nipped a running blade of a table saw once. I was being stupid. Actually, was I being stupid? No, I was just distracted for a moment. I knew what I was doing, and I let my mind go somewhere else. I'm just gonna rip one more board because I was building some steps, and the wet green treated decking material got stuck into the guard that I had, and when I reached back to unstick it, my finger hit the whirling blade. It won't ever happen again. I fully always think about and respect, and I always, when I'm about to use a power tool, I think about how I'm going to use it, what I need to do. I almost do like a self-check or a self-job hazard assessment to make sure that I am wearing the proper equipment, that something can't accidentally fall over or happen while I'm doing the cut. And if I do, I have an exit to it. I'm just going to shut off the power or step away, whatever it might be. Should do that stuff. So with hand power tools, primarily it's PPE, but you should also make sure that you're using it properly and almost do like a self-check before you use them. We're going into like a higher level woodworking, so not really handheld anymore, but we've got a radial arm saw up on the top. We've got a table saw just below that. Or no, sorry, that's a router table. Looks like the person on the bottom right there who's holding up his shirt, that looks like it was from kickback. So when you're using a table saw, you should stand to the side, and also just beyond the blade guard or cover that usually floats, there should be some teeth that grab onto the board once it hits a certain point to prevent kickback. Kickback is when the table saw hits like a knot or a change of fibrous material in the board you're cutting that you typically can't see, and it ejects the wood at a high speed. And so that dude took a board into the gut, took it like a champ. So then they've got here, you can see right next to him, there's a splitter, there's the anti-kickback prong, so that prevents it, but still you should stand to the side. And I also like to use a dowel, similar to the pushback that the girl is using there. I keep my hands away. And if I'm cutting something longer, I will then get my wife or my neighbor, and we'll do all feed and they'll catch, just to keep away from the blade. Here we've got a drum sander. Oh, no, that's not the right term. It's a reciprocating cylindrical sander. A drum sander is something for floors. So with these, it's spinning. And so what you want to make sure is that you're not wearing jewelry, loose-fitting clothing, your hair should be tied back, but also make note of the hex nut on top. We call those knuckle busters because if you were to get your hand close to it, it would nick and really mess up your hand. And then we've got a person over here. It looks like they're using either a skill saw. No, is that a bandsaw? Bandsaw or a jigsaw? Yeah, I mean, you're supposed to, with those, any sort of like bandsaw, you're supposed to guard the unused portion of the blade itself. And PPE should be worn with all this. All this stuff tends to be really loud. They tend to have projectiles. So face and ear PPE required. Not necessarily wearing gloves, because gloves could actually cause a problem with this stuff. It could cause someone to be pulled in. I don't do welding. Okay, sorry, that looked weird for me. I just want to make sure it's not weird on the video. Welding, I've not really done welding. The most I've done is soldering. So I've sweated pipes when I'm working with copper. I like to work with PEX now. And I've done soldering for electronics. But as far as doing a weld, not my area of expertise. But the ultraviolet light or the infrared light, I forget which part of the spectrum it's on, can actually burn your retina. And what I hear is if so that's why you have to wear the welder's helmet or have special type of eye protection when you're doing, especially arc welding, but any type of welding. You shouldn't look into the actual bright light. What they say is it feels like you have an eye full of sand, and it doesn't happen right after the exposure. It's like hours later, and it's very, very painful. And typically you have to go into the doctor to get treated. Now, welding fumes is another issue. The stuff that, the smoke that comes off. Typically you're working with like a smoke eater or local ventilation, so that it's drawing it away from your face, although it isn't for that person on the bottom there. There's also, the sparks and arcs that are flying off that can either burn you or cause a fire. So you're supposed to actually clear all flammable materials, I think 25 feet away, if I'm not mistaken. It's 25 or 30 feet away. That's what the standard says. So you have to wear PPE. You should have something capturing the fumes. You have to clear out anything that's flammable. Also, the tanks themselves are pressurized gases. And if those were to accidentally tip over and the nozzle was to become, or the valve was to become damaged, these things can come torpedoes and actually really hurt people. Did I hit everything? Wow, I actually did. Oh, it can be loud as well. So there you should also have someone, if you can't control all the flammables, you have to have someone on fire watch. So once the welding's done, I think fire watch is supposed to stay active for like another 30 minutes to make sure no embers catch. It can be a real big issue. All right, let's move on to metalworking. So we've got lathe, we've got drill press, we've got just a power press here on the bottom. The big things with these are the point of operation. There may be shavings, there may be metal fume, there may be cutting fluids involved with these. Cutting fluids are meant to keep the temperature down a little bit. It's meant to also help clear the debris so that the cutting mechanism doesn't get jammed up. So you can see here, respiratory could be an issue. Noise is usually an issue. Projectiles are definitely an issue. And depending if it needs cutting fluid, I've actually worked on cases in which cutting fluids have caused sort of dermal rash or negative reactions. These machines all require some form of protection as far as guarding because, again, the point of operation. You want to keep it away from the operator. Power presses, this is they can be stamping or they can be, typically you see them as doing stamping. Some are continuously running, so they cycle. Others are hydraulic. If you remember the movie 8 Mile with Eminem, Mom Spaghetti, his job at that company he worked at, he was a press operator. His partner was like up, down. They both had 2-end actuators. And so in order for the press to cycle and do the stamp, they both had to be pressing down at the same time 2 buttons. So none of them could get into the machine while it's operating. And that's usually the principle used with power presses. I hope some of you know what I'm talking about when I talk about 8 Mile. I hope I'm not that old. Anyway. More and more we're seeing automation and robots used. The thing is, a robot is, basically designed, told to do these things, whether operating an arc welder or doing assembly or whatever it is. And usually the sort of the range of operation, the cone of operation is fenced off so that no operator, because a robot isn't looking out for you. It doesn't have feelings. It doesn't know when you're there. So you have to institute presence sensing devices, whether that's a gate with an interlock, whether that's a floor mat, whatever it is, so that the robot stops operating when a human comes near, because it doesn't know. Though they have now advanced sensing technologies that actually, I don't know a lot about it yet. This is just based off what I've been reading from the ANSI standards with machine guarding, is that if a robot has presence sensing built into it, then you don't need the gates. But I still think you should have the gates and some form of presence sensing as sort of a backup. Because if you have an interlocking guard for a gate and the gate is opened, thing is supposed to stop. But what if it has potential energy? What if it's spinning around or still moving or still has energy and the person gets in the way? They still could. So are you also instituting not only stopping, extending the power to it, but you also have a braking system to stop it from running? I think of that like when I'm working with a saw. It's like I let go of the trigger, the actuator, but the thing still spins. So there's still a danger even though I've turned off the power. There are plenty of references for proper machine safeguarding, whether it's presence sensing, permanent devices, or something you do with actuation in order to keep the person away. When the machine is not being used in normal operation, but being maintained or worked on, or you're changing out a bit, a die, a blade, whatever, the machine needs to be locked and tagged out. That's what LOTO, lockout, tag out. It's 1910-147. This is energy isolation and release. So you, for larger industrial machines, it's like a list, a checklist you have to go through. You have to cut the power at this point, and then you lock that out. You need to turn off the pneumatic or the pressurized air, lock that out. You need to let it cool down, or you have to put in blocks because something could fall. It's got potential energy. You do all these things on a list, and then what you do is you turn on the machine and release any stored energy safely before you start working on it. For you and I, it's simply, most hand tools, things we have around the house, we unplug it. If you can unplug something and you can remain, in control of the plug, you don't have to do lockout tagout. That's the one exemption. And operators sometimes are not even allowed to touch a machine while it's in maintenance or repair mode because you have to be trained. There's affected workers, and then there is another term I should know. But it's typically maintenance or engineers who are the highest level trained, and they know how to properly isolate, release energy, and then work on it. And the idea is if you have multiple people working on it, you want to make sure, my nose is itchy, sorry. Make sure somebody else doesn't activate or remove a lock and then turn on an energy source without everyone being clear. So some machines need both a lockout tagout to isolate and de-energize, but then also startup. A sequence in which to make sure that the machine isn't affected by, one aspect of it jolting alive where the rest are still, cold and damaging the machine. And then, of course, there's always signage. There should always be signage. And I do agree that any sort of guards should have some sort of yellow with black tape notifying that it is a guard in place. These are, now anybody asks me questions about this stuff, I go to the experts. Rockford Systems, definitely an expert. They send people out to specialize and customize machine guarding for companies, though they offer classes as well, and very good classes. Right Height does it. Brady Corporation and Master Lock are the lockout tagout experts. I've got just a Master Lock kit here. What's great too is these experts, who provide services and training, also sit on ANSI standards committees and write the standards that we must follow. So covered a lot, got a lot of chapters to look at, provided some videos and some other stuff to read. But I think you kind of get the overall gist of the struck by cod end. It's almost a continual concern. So we do the best we can to design out, I don't want to say dummy proof, but just distraction proof. Yeah, to be able to fail safe is kind of the goal to prevent struck by cod end injuries.